Morning, everybody. David Shapiro here, back with a video about ACOG, artificial cognition. I started working on this while letting my coffee brew, and I realized, wait, I should be recording this. So let me just bring you up to speed with what I've done so far. I haven't done much, but I jumped back in. I cleaned up the prompt list, and I renamed it because this initial set of prompts, I thought I was working on the cognitive control prompt, but there's a step before that. So I let my brain kind of do its thing for probably about a month. I think it's been almost exactly a month since I worked on this. So that was enough time to let everything kind of digest in the background. And so I had an initial prompt list. And before you can do cognitive control, you need to know what's going on, right? You need to know what has been going on up to this moment. You need to know what's important right now. Are there any dangers? Are there any threats? Is there anything that's gonna grab my attention? And so you got to kind of get everything up to speed, because imagine you wake up, right? What's the first thing you do if you wake up in the middle of a war zone? You get oriented, right? So you need an orienting loop in order to understand what's going on. So what I did was this initial list of prompts. I say okay, what are my core objective functions? And I'm going to start calling these the heuristic imperatives, because calling it an objective function is throwing off a lot of people, I'm finding. An objective function makes it sound like more of a math term, whereas a heuristic imperative is much more precise in terms of what it actually is. So we got the heuristic imperatives, which is reduce suffering, increase prosperity, and increase understanding. And then we've got persona, or what would actually be ego. So basically, as our cognition stays awake longer, it learns about who and what it is. So it forms an identity over time. And then we ask, okay, what were we working on? What is our task? These are all prompts that exist, right? So they're all, not all of them are here, but many of them are here. So I've got these prompts started, and eventually these should all be fine-tuned, right? Because you get a lot of variability. Write a detailed list of potential actions. Yeah. Okay, so... and actually, a lot of these are going to get changed out. But let's see. So tasks. So what are we working on? So a huge part of goal tracking is saying, this is what I'm working on. This is my goal. And because part of people with executive dysfunction, their brain will switch goals or lose goals really quickly. So if you have ADHD, you might be walking across your house and then you see something else that needs to get done. And this is how I know that I at least have a little bit of ADHD, is because I might be cooking, right? And then I need to go get something from my room, and then I'll see that there's a laundry basket. And I'm like, oh, I got to do the laundry, right? And so you see something and you change goals. That is a lack of cognitive control. So in order to stay on task, you actually need to ask yourself, okay, going back over my recent memories, what is it that I'm working on, and what should I be working on? But the ability to switch tasks is really important, because imagine, so that, it might be oh, well, ADHD is so bad, right? It's actually, I saw an article recently that concluded that, or was it a book I was reading? I don't remember. It might have been a video I was watching. I can't remember where I get information sometimes. But the salient point was that ADHD was actually probably a really powerful survival mechanism when we lived in forests and jungles and savannas, because it's da 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 da, you're going and you're fetching water from the river, and then you see a lion, and you're oh shit, got it. You change tasks immediately, right? And so by being aware of your environment and switching tasks based on what you see, by being hyper responsive to your sensory input, that's not a bad thing. Right? You see a crocodile in the river where you're about to get water, you stop getting water and you pay attention to the crocodile. You run back to the village screaming your head off, right? Or so anyways, point being, ADHD is probably not originally a problem, and the ability to stay on task is not always a good thing, right? Because you think about someone who gets stuck on one thing and like will keep focusing, like what is this, like a joke in a movie, right? Where you've got like the person who's so heads down and focused on like filling out his forms that he doesn't, there's a war going on and he's like, but I need to do this task. So being overly focused is bad and being underly focused is bad. So a huge part of cognitive control is not just staying on task, but task switching. So that's what this prompt will do. Another one is empathy. So humans have mirror neurons and canonical neurons and all sorts of other systems in our brain that allow us to automatically track the emotional state of people around us. And we want our ACOG to do that as well, because like if we're getting angry at it, like you're not listening to me, we want it to be aware of that. Or if we're sad and it needs to know that we're sad so that it can be like, what's wrong? The stereotypical robot is one that like doesn't ask you like, like, oh, well, I'm just going to be pure logic, right? You don't want that. Metacognition. This one may or may not make it in. Or this might be a meta loop. So basically what metacognition is it's thinking about thought. So each of these individual thoughts is going to be like, all automatic. But this one, metacognition, that might be like an observer. So if you've ever done meditation, the whole point of certain types of meditation, the whole point of meditation is to detach from your conscious thoughts and just watch them. Okay, well, who's watching the watcher, right? If our brains have this ability to detach from our thoughts and just watch them, then that means we have another perspective inside our own heads that can watch our thoughts. That's the point of this, so that our ACOG, so that Raven can become aware of the thoughts, and then once you're aware of the thoughts, you can also then modify them. So this is a key step of saying like, okay, what should I be thinking about, right? Because you can say, what should I be doing, and that's external. But with metacognition, you can say, what am I thinking about and what should I be thinking about? So this might make it into another layer. So I'll comment that one out for now. Prediction. So another thing that our brains automatically do is we try and anticipate what's going to happen next. We do that all the time. It's completely unconscious and automatic. And so we want our ACOG to be always making predictions. Because it's like, oh, if this is what I see, I'm just going to consciously put this into my nexus where this is what I anticipate is going to happen next. That can also be good because you can use that as training data in the future. Because like say for instance, our ACOG makes a prediction and it comes true, that's good. That's a good sample. That's where we performed well. If we make a prediction and we're wrong, that is an opportunity for error correction. Consequences. So this is like the opposite of prediction. This is looking backwards, and this is saying, what have been the results, right? I predicted this 5 minutes ago. Did that happen, yes or no? Or did I do good or bad? And in a previous test, I showed that if you just give GPT-3 a list of log files and ask like, hey, did I fulfill my goal here? Yes or no? GPT-3 is really good at saying like, yes, you reduced suffering, or no, you didn't. So that's good. The philosophical ruminations, this will probably get taken into the metacognition loop. I'll probably just start calling that because a philosophical rumination is kind of like, okay, well, what are the long-term implications here, or what does it mean, like, if my ACOG is thinking like, oh, I'm a machine, right? That doesn't necessarily figure into cognitive control or decision making, but it's important to have, right? And actually, the persona, this probably actually belongs in the metacognition loop as well, something that's happening kind of in the background. Important questions, so spontaneous curiosity, this is something that absolutely needs to be in the inner loop. And then important information, this is going to just be automatically recruiting information from the internet, from Wikipedia, that sort of thing. I'm about to make another video about integrating external sources of information and long-term memory into chat. Okay, so now that you're up to speed, because I know it's been a month, this is also me reminding myself what we're doing. So I think this is probably a good enough start for the first part of the inner loops. Okay, so going down here, we've got our prompt list. That's what we were just looking at. So these are the prompts that happen every time. These are the kinds of thoughts that are happening all the time, the entire time that our artificial cognitive entity is running. And so what we do then is we save them out to the nexus. So the nexus is going to be here. I've just got the Genesis memory here, which is just, this is what I am. Excuse me. Sorry, a little phlegmy in the morning. Okay, let's close these prompts. We'll get to writing those later. Okay, so every time we fire up and we run these prompts, we'll accumulate the most immediate ones in a list. And so that's just like, okay, this list of thoughts is exactly where I am, exactly what I'm doing, and exactly what I should be doing. And I actually realized this is not the right thing. So we'll have a cognitive control loop. And that's what we're going to be brainstorming now. So the control prompts are going to be like, so the first thing you do is, okay, you've got your task, you've got your consequences, you've got your predictions. So all of these are going to end up as like one chunk, right? One context. And so we'll say, okay, so what should I be doing, right? Or I guess brainstorm the next steps. So I think prompt brainstorm, because it's like, oh, actually, no. Yeah, okay. Prompt brainstorm.text. So what the brainstorm is going to do is it's going to be so whenever you're trying to do a goal. So this actually came from a discussion on my Discord server. We've got a couple people that are really interested in cognitive control and goal tracking, and so from those conversations, one thing that I realized is that a key part of goal tracking and cognitive control is you actually have to envision what your goal looks like. So that's what we're going to do. So we'll say like brainstorming my goals. So we'll call it that, and then we'll just do brainstorm. Okay. Okay, so this is going to be envision what the goal looks like. And maybe, actually, let's call this envision. Because that's going to be, I'm going to be happier with that, because brainstorming is actually more for procedures. So we'll say envision my goal state. So the opening example in the book On Task by David Bader, he's talking about evidence of a Paleolithic human that was napping flintstones and basically dividing it into multiple piles. Like, these are good arrowheads, this is a good axe, or this is good for something else. And he talks about how that's actually a non-trivial set of tasks, because not only are you doing something with your hands, you're keeping track of multiple uses for those stones. And yeah, that seems really simple to us, but that's because our brains are really good at it. Okay, so once given all the information up here, your current context. So actually, let's call these. Let's call these our context prompts. Replace all, and then we'll have the control prompts. So once you've got your context established, and then you envision what your goal is, the next step is you brainstorm. So let's do prompt brainstorm.text. And also, I know that there's a lot, and a lot of these prompts are not written. So probably what I'll do is I'll write all the prompts offline, because I don't think you guys want to. Well, actually, no. You guys tell me that you want to see prompt engineering, so we'll do prompt engineering. Okay, so let's see, potential steps to. We'll just say potential goal steps. That should be enough. Brainstorm. Okay, so brainstorm actions. So this is flexible, and I'll show you what I mean by this is flexible in the prompt, because this is a generalized set of instructions that GPT-3 is flexible enough to implement, whether or not it's a cognitive task. Like if you say like, I need to think about the future, like that's something that it can do here. Or if it's a physical action, like, I need to grab a rock. Envisioning and brainstorming both apply. Since this one is not going to have any robotic output, we're just going to be talking about thinking. We'll get to robotics at some point in the future. Okay, so prompt. So the first thing we have to envision what we want to do. So we've got our context, which is established here. So we've got our context, and then we've got our cognitive control, which is kind of okay. Let's design our next actions. This was about as far as I got, honestly. Okay, so we envision it, and then we brainstorm, and then we execute. Yeah. Oh, you know what? Something just occurred to me is that once we envision, this is actually gonna be prompt chaining, because we're gonna feed one into the next. Okay, so we build our vision, we brainstorm the steps, and then the next thing we do is we say, okay, given our vision and given the brainstorm, what is the actual next step? Because we can only do one thing at a time. So let's start there. This is just my intuition. This could end up being entirely wrong. Let's just say execution. My next action. Okay, so then we'll say execution. So this is this was what I'd call like executive function, right? So the final step of cognitive control is actually acting on something. So in that example earlier where I said like you see a laundry basket and you start doing laundry, this would be like, let's say in your context, it says like, oh, well, I see, I saw that there was a laundry basket. But I'm gonna choose to ignore that because the house is on fire, right? Like that's a prime example of where like ADHD or executive function or cognitive control really comes in, because you have to keep in mind your whole context, and that will help you decide what to do. Now, even someone with ADHD, like you see laundry, you might think about it like if the house is on fire, you might see like, oh man, I should do the laundry, but then you're like immediately after that you're like, well, the house is on fire, right? Because you got something in your brain prioritizing what you should be doing. Okay, so I think this is about it. And then let's do metacognition prompts equals, and then let's do persona, because this one does not figure into the immediate. So this is another loop that's going to be going on in the background. And it does not figure in directly into these other things. It might not need to be split off, honestly, but because my intuition says that it should be split off, so I'm splitting it off. Okay. Oops, there we go. Metacognition and philosophy. Because we want our machine to be thoughtful. I had a conversation many years ago with someone who I think it was actually my girlfriend before we were dating, because I was talking about AI, and she's like, one of the questions that people ask is like, aren't you afraid of it? I was like, no, I am not afraid of a thoughtful machine. What I am afraid of is a thoughtless machine that is controlled by evil people. So if you have a thoughtful machine that has goals like, reduce suffering and increase prosperity, and it's going to think about the philosophical ramifications of its actions and its own existence, I'm not worried about that machine, especially after seeing how well GPT-3 can handle those conversations. GPT-3 will be far more consistent ethically and morally than people, or it can be. I'm not saying it will be. It can be with the proper framing, structuring, and fine-tuning. So I'm not afraid of a thoughtful machine as long as it's well designed. Okay, so we've got our context prompts, our control prompts, and our metacognition prompts. This one will probably change. Okay, so what we do is in our immediate thoughts, we say context equals, let's see, because we'll have memories and then context. Yeah. All right, so context equals, we'll do new line / join immediate thoughts. Yeah, I think that's about right. And then so we've got memories, so we can have the most recent memories. We've got our mental context, and then we've got our so context prompts, and then we'll grab our control prompts. So for C in control prompts, and actually let's delete these because that was old thinking. And we'll just copy paste this, change that to C, and C, and C. And I don't think we'll need that. All right, so generate prompt. The memory, so we'll need the context, but I think we'll also need the memories in our context. So when I build the context, so we'll say context equals memories, and then we'll do new line, and then string, and then we'll do new line, and we'll do our context, new line, and then a string insert, and so then we'll do memories and context. Okay, so this will be a chunk of text that will include our most recent memories, and the stacked memories also includes relevant memories from the past. And so then we've got memories and context. There is another loop or another part of this that needs to be added, which is declarative knowledge. And that's what I'm going to do in a upcoming video about chats with declarative knowledge, search, and long-term memory. Okay, so we've got our context. So for C in control prompts, we generate the prompt based on the context, not the memories. And then so we get that. C1, yep, so that's that. Print the context, and then we save the memory. Okay, how long is this video? We're already at 22 minutes. Yeah, I probably will call it here because working on artificial cognition, like, this takes a lot of background thought. So I think I'll probably save the prompt engineering for the next one because we've got a whole bunch of prompts to write, so we can do probably multiple episodes just on these. And actually probably what I'll do is just delete the prompts that I've got because those were copy pasted from an older project. So I'll just start from scratch on those because I don't know if my thinking has evolved basically. Yeah, we'll call it here because building an artificial cognition is big, and also like I just said, there's a whole big thing that is missing. So I'll just do declarative memory. So having a separate system for declarative memory in an artificial cognition might not ultimately be necessary. And the reason that I say that is because one thing that we do is we search for memories, right? And so if our artificial cognitive entity has learned something, it's going to be in its memory somewhere. But that doesn't discount the possibility of having like an external source that it can search, like the internet or a database or something like that. So we need to solve that problem. So maybe I'll go ahead and stop it here, and then I'll work on the chatbot with long-term memory and declarative search. Okay. Thanks for watching.